Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be ammonia. Ammonia will be the last chapter before we head on to the final stretch of topics under the theme of organic chemistry. So ammonia is also a pretty small chapter. Let's get to it. So ammonia is NH3. It is formed by one molecule of nitrogen with 3 molecules of hydrogen to form ammonia in this equation. And do note that it is a reversible reaction. This is a little bit different from the usual one direction chemical reactions we've been talking about from the previous chapters. So this is one example. This is yet as also another example. And so if we want to have more of the products on the right, that is ammonia, we have to design the manufacturing process in such a way whereby we can control the parameters such that it favors the forward reaction more than the backward reaction. So what process is this? It will be produced by the process called the Haber process. Of course, the person who invented it is called Haber, Fritz Haber. And the conditions are these: 450 degrees Celsius, 250 atmospheric pressure, and ion catalyst. And the basic schematic will be this. The proportion of nitrogen to hydrogen gas will be in 1:3 volume. Recall that in molar volumes, gases react in proportion of their molar volumes. And so this compressor will create the pressure condition, and it's being channeled into the converter with the ion catalyst and the temperature and pressure being 450 and 250. The converter will be providing the ideal temperature and pressure, and the condenser will collect the liquid ammonia, which will be channeled away, and the unreacted nitrogen and hydrogen will be pumped back to the converter to maximize the output, which we call the yield per input of raw materials. So at any one point of time, it's only about 10 to 15% of the nitrogen and hydrogen being combined to form the ammonia. So it's very important to channel back the unreacted gases to increase the production. And so with the production of ammonium done, next we're going to talk about displacement of ammonia from its salts. So recall that displacement is just like substitution. One person goes in, another person goes out. Or in the reactivity series of metals, I like to tell my students is the snatch boyfriend, snatch girlfriend mechanism. So take a look at this reaction: ammonium chloride and sodium hydroxide. So of course, sodium hydroxide being the strong base and sodium being a reactive metal, it is going to kick out the hydrogen to give you the hydrogen gas, water, and the salt. Same calcium hydroxide is calcium being pretty high up in the reactivity series is going to kick out to displace the ammonium cation away from its anion to produce calcium chloride. And also ammonium salts, when you heat them, they will produce the ammonia gas. It undergoes the thermal decomposition. And do note that all these displacement reactions, they require heating. And also in questions like this, because ammonium is a important source of nitrogen to create salts for fertilizers for plants, there's a lot of questions that I will ask you about NPK, the nitrogen, phosphorus, and potassium. These are important nutrients for the plants, and they can be obtained from salts that come in the form of these two: ammonium nitrate and potassium phosphate. Usually the raw ammonium will not be stable enough to hang around in the soil for too long as a source of nitrogen for the plants. That's why it's in the salt form. In addition, there's this earlier topic about adding calcium compounds, liming, to increase the pH of soils that are too acidic. Adding too much of this will be a concern because it will be able to displace the ammonium salts to release it as ammonia gas, like mentioned in the displacement topic earlier. So the soil is going to lose its nitrogen content and therefore making it less fertile for the plants that are in it. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!